Okay, let's see. Okay, yeah. Okay, so last class, we already started discussing Q implemented with circular array. Oh. And I remember we are almost done with this Q implemented with a circular array, okay. And in this Q, we implemented with a circular array. We also implement the clonable interface and the iterable interface. And so let's go over here. So this just a quick review. Okay, so this is our Q implemented with circular array. Okay, and so for the Q constructor, this default constructor, and remember, okay, constructor needed to be the same name as the class name. And for default one, you don't have any parameter, okay? And in this case, because our instance variable is an array, so one of the instance variable is an array, so you need to allocate memory, okay, for this array, okay? So keep this in mind also. And the second constructor, this is the second constructor. This second constructor, we have parameters. So we are going to initiate array with whatever the initial capacity specified here. Okay, so that's, and then for enqueue is to add an item at the back, is it? And the first thing we need to check, because here we use array to implement, is it? And array has capacity. So if array's size is full, then we are going to throw the Q full condition, okay, Q full exception. Otherwise, you're going to add the item at the back. So add the item at the back. Over here is just you assign the element to the empty slot. And remember this back index, so keep this index in mind, okay. Back index point to the empty slot. And that slot is one beyond the last item. And why we need to have an empty slot is it's because we want to differentiate between empty condition and full condition, okay? So when the Q is full, is it? When Q is full, the condition is a back index plus 1, then module the capacity, is it? So in this case is the array's length, is it? Is going to equal to the front index. Okay, so that's the Q full condition. And the Q empty condition is front equals to back. Okay, so that's the empty condition. Okay, then let's see. So then what we are going to do is we are going to have we also needed to advance the back index, is it? So over here is you advance the back index to the next available one, is it? Yeah, so that's enqueue, okay. And for dequeue, DQ, if Q is empty, then you just throw empty condition, is that exception. Otherwise, you advance, is it? We call this not just plus plus, is it? Because this is circular array, is it? And we need to deal with that wraparound. We can deal with that issue with the module, is it? So this advance your front index by 1. Okay, so that's what for the DQ. DQ is to remove, okay? Remember, remove at front, because that's Q. Q's feature is FIFO, is it? First in and first out, is it? So this is for DQ, okay? Okay, then next let's see the front item, is it? So we are going to retrieve the front item, and you just get access the first element, is it, in the circular array. But of course, you need to make sure Q is not empty, okay? And empty condition we already discussed. And the to string is just 1 by 1 item from front to the back, is it? And how do we do this loop here? Be careful, okay? So the loop termination condition use not equal, okay? And you increment the loop index by 1 here, you need to take care of circular array cases. Okay, so that's to string. And the clone method we also discussed is we need to do deep copy. Is it? In order to deep copy, you need to create, you can create a new queue, is it? And then the new idea over here is that iterable interface. Is it? And that interface has a method called iterator. And the iterator method returns an iterator. Okay, returns an iterator over here. We implement, we say, okay, return some new iterator we call Q iterator. And in our class, we implement this inner class. This Q iterator is an inner class. And this inner class implements iterator interface. Okay, iterator is an interface also, okay? And this iterator has 3 methods generally you need to override. Has next, next, and remove, okay? And this iterator interface then will allow you to advance in a collection 1 item by 1 item. Okay, that's how this iterator works. So you can start at some, so start at some specified location. Okay, so depends on position. In this case, depends on where you want to start. Okay. And then it can be advanced 1 by 1, okay? So that's the idea. And in our case, okay, so for this Q iterator, we have an index. So this index can help us to advance in the array 1 by 1, is it? So we start with our index at the front index, is it? So we initialize our index to front. So we let our iterator start at the first item in the queue, okay? Then this has next. And this has next because over here we use circular array, is it? We use circular array. And you want to check, you start at somewhere, Is it suppose here is the front index? Is it? And you start, suppose this is 70, is it? And 80, and 90, 100, 110, is it? And then here is going to be back. Is it? So what here you are going to do, you're going to start at this first item, is it? And then you're going to check if the next item is available or not. That's what this method means. If this collection still has more items for you to visit, is it? And our index start here. Is it? Start at the front index. Is it? And you want to check if next is available. Is it? And how do I check if next is available? And of course, if you advanced to the back index, to the empty slot, that means you already reached the end of this queue. Is it? There is no more item for you to visit, is it? So you should stop, is it? So that's how we deal with this. Then we can do index plus 1. That's generally what we think, is that the next index is plus 1, is it? But over here, because this is a circular array, is it? And to handle circular arrays, special cases, generally we can do module and the array's length. Is it? Then we can get around
I have a question.
Issue. Yeah, please.
Shouldn't it be equal rather than less than equal?
Equal. No, you cannot make it equal. Then that's going to be, you see. Okay, just let's see.
Oh, well, not equal. Sorry, maybe like exclamation point equal.
Yeah, if it is equal, then that will not work. Is it? Yeah, you say that if it's not equal. Yeah, if it's not equal, yeah, that will work also. Yeah, that will work also. But if you do this, that will also work, less than. And both will work. I agree. Yeah, so not equal will also work. Okay, but let's see the idea. So first,
what if m back is less than this? Like that can happen, right? And
yeah. So in this case, is it? So if you want to check, so suppose in this case, is it then back is 5? Is it? Back is 5. 5 plus 1, it's 6. And 6 module 6 is 0. Oh yeah, I'm sorry that when index, yeah, so it shouldn't be equal. Okay, then in this case, yeah, it's already reached the end, so I shouldn't have equal, just less than. Okay, so it's 0. Is it? 0 is so this is your index plus 1. Is it? Index 1, it's 0, so it's not going to meet this condition. So you're going to return false. Is it? You're going to return false. But otherwise, it will work. Is it? But let's see. And if we have this not equal, okay, if we have this not equal, and over here, your back is 5. Back is 5 here. Is it? Index is 4. 4 plus 1 is 5. 5, and then you have 5. So you cannot, so it's already reached the back. Yeah, so because 5 equals to 5, that's going to work. Okay,
I just think that if m front, for example, equals to 4 and then m back starts at 1, then it won't work.
Let's see if that's, let me clear this out, okay. You see the front. Okay, so here, so here is sub 0, sub 1, sub 2, sub 3, sub 4. Okay, so suppose you have an item here, is it? So it's front, is it? The front item, and where you want to have your back item. Back, you mean at sub 0?
For example, 1.
You mean here?
Yeah,
Here
or
is
0
back.
or 1.
Here is back, is it? Then in this case, I have suppose 110 here. Is it? Suppose 110 and 120 here as sub 0. Is it? Sub 0. Then my index started here. Is it? My index start here. So index start at sub 4. And then you plus 1, so you still have, is it? So it's a sub 5 here, and then over here I jump back to 0, is it? So index. When index is 5, then you can jump the next one if you want to move. Is it advance? Then it's 0. Is it? And 0 plus 1. 0 plus 1 is 1. Is it? And 1 module 6, I still get 1. Is it? And 1, so I need to. So 1 is not less than 1. Is it? So that's still work, is it?
I'm
so
sorry
this,
for taking your time, guys, but yeah, one more thing. I just think that if we have index 4 and 4 plus 1 percentage 6, it will be still 5. But 5 is not less than an back.
Oh, okay,
but
yeah,
still
I
have
got
as
messed
next.
up. Yeah, thanks for reminding. Yeah, I got messed up for some reason. Now I see it. Yeah, sorry. Yeah.
Sorry
Okay,
for
let's
taking
got back. Yeah. Okay, thanks for reminding. Yeah. Okay, I got messed up here for some reason. Okay, yeah. So this is sub 5, yeah, and this is sub 4. Okay, so my index right now is at 4, and you have 100, suppose. Okay, and so you mean that here is sub 0 and here is sub 1. So this is the back index, yeah, and yeah, that's correct. So mine's not working. Thanks for checking. Okay, thanks for checking, reminding. Yeah, so we should use not equal, yeah, instead of that less than. Okay, so that's not correct. Yeah. So we should use not equal, yeah, because otherwise in this case that will not work. Okay, so so anyway, so here has next is you want to check, okay, if you still have next. So in this case we have 110, is it? So then your index can be advanced to 5. To 5, is it? And in this case, 120, then it can be jumped back to 0. So over here, this work. But here, yeah, I need to correct the example. Okay, so it should be not equal. Okay, as next. So this is to just check. Okay, if you have the next item, and then you also want to get the next item. This is the next item. I want to get to the next one. You first check if you have the next available. Is it? If you if it is available, is it? You just get whatever the index currently point to. Is it? Then you advance your index by 1. Is it? And here, because of circular array, same issue. Is it? So we need to do the module operation. Okay. So that's next to retrieve. And the last method here, we didn't implement remove. Okay, but you can think about it. How do you do remove? Okay, so this is going to be a little bit of complicated if we want to implement with array. That's why I just leave it not implemented, okay, because that's not a good choice if we use array to do remove. And here it's remove, just not remove from front. It can remove any item wherever the index point to. Is it? So if the front is here, is that sub-0 and 100? Is it? And then your index may be here. So 110, 120, is it? So your index may be here, and you want to remove this one, somewhere in the middle. And if we want to move somewhere in the middle, you see here, it's not you just update the index. Is it? That's not going to work, because then you also destroy your queue. Is it? So over here, if you want to implement the remove, and also using circular array, it also involves shifting. Is it? You also need to shift all the following array items. Is it? Move it to the correct location. Okay, so that's why we don't want to complicate in this case. And so we didn't implement. But why we need this iterator? Is it? So iterator is not just allow you to advance. Is it? It will also allow you to remove. Allows to remove also. Okay, so that's why we also put forward this iterator interface, okay, so that it will allow you do advance at the same time. It also allow you to remove. So here the key point is something like this. So let's just think about a linear way. Okay, linear way. So when you have the item, is it you removed, is it? And a lot of cases, if you just do it, then it will lose track of where you are. Is it? Because this item is already gone from this collection. Is it? If we don't have something to keep track, then you will lose track of where position you are currently is. Is it? You're supposed to move to the next one. Is it? But if you remove it, and then you will lose track of it. So there's some issue. Is it? So that's why over here we provide that remove method. The remove method will allow you to remove one, but it will let you, so it's a loop, is it? So that even though you remove it, you can still do the iteration. So you can still move to the next when you do the next iteration. Okay, because generally speaking, when we talk about the loop, is it loop? There are two kinds of loop, is it? And especially for for loop, is it? For loop is determinate, is it? So determinate loop, is it? So it's a fixed number of iterations. It's a fixed number. Fixed number is supposed here you are going to loop 10 times. But just think about, then you remove something. You remove something, then you will only be left with 9 items to loop, to iterate. Is it? You have one short, but your loop itself will still conduct 10 times. So that won't work. Is it? So that's why if we provide this iterator, then that can solve that dilemma. Okay, so that's the purpose. Because you may ask, then why do we need this? Is it? So anyway, so this iterator will return an iterator instance. That iterator instance will implement the iterator interface. Okay, and that iterator interface implement this has next, and remove. Okay, and I should update here. It should be not equal, is it? Okay, so that's the about this this Q class itself. Okay, then next let's take a look at the application part. Okay, of this Q. So over here, I remember last time we also discussed this part, is it? So we have a Q created, is it? Then we add items to this Q integer, is it? And then we also call its front empty and to string, is it? And in Q, is it? We call off those methods. And we have two methods, two kind of search, is it? Two kind of search. And over here is if Q is not empty, then you can dequeue. We saw that a lot. And here, because we have exceptions, so that's why you needed to also take care of the empty and full conditions with the exception. Okay, then let's take a look. This two search. And this search, I remember I already discussed, is it? Because you are going to search an item in this queue. Is it? In this queue, you cannot access that array, is it? So the only way you are going to do it is you keep compare, is it? Keep compare with front item. With front item, is it? But if you keep compare with, you need a dequeue. Is it? And if you do the dequeue, you will modify this queue. Is it? A lot of time you don't want this queue be modified. Is it? Then in this case, you can call that deep copy. Is it? Clone method. Is it? Then in this case, you can call front and dequeue on the clone one. Is it? On the clone one. So that's this search method. Okay, it's pretty straightforward. Then the second one, our search to method, same thing. We want to search an item in this queue, is it? And if you take a look over here, this is that for each loop, is it? And why you can use this? It's because, just keep this in mind, okay? It's because our queue, so because our queue implements this iterable interface. If the queue, if you remove this, if you take off it, okay, then this will be illegal. Okay, then you cannot, you can try. Okay, then you cannot use this loop. Okay, for each loop. So in order for a data structure to support this kind of for each loop, you need to implement that iterable interface. And that iterable interface will give you what? Iterator. Is it? And that iterator will take care of how to advance. Is it? Because it has the has next to check and the next method to return the next item. So basically internally, even though over here we didn't have that has next and next, and basically internally it call has next and next. Okay, it's equivalent to use a loop to check if it has next, and then it call next. So why it can get the item, it's because this one calls the next. Okay, that's why it can get the item from the queue. It's because of this next call, even though we didn't see it here. Okay, so Java already take care of that, so that you can write this for each loop. You use this for each internally, basically it call has next and next. Okay, so keep this in mind. Okay. Okay, so that is this example, and within this example, I also, because you remember we also have those empty queue exception, is it, and the full queue exception. Basically, this I created this two exception as a class, and this two class extends from our runtime exception. Is it? It's pretty straightforward. Is it? So it's just has a constructor. The constructor just calls superclass constructor, is it? So it's a pretty simple one. And the same thing for the full full class, okay, exception. So same thing, you just extend that runtime exception. Okay, so that is this example. And then next, let's take a look at the other example, okay, for Q. Okay, this one. The second example, this time, if you take a look, our file, we only have this single file. We don't have our Q class. So over here, I import from Java a Q. Okay, and this Q is Java Collection Frameworks Q, and it is an interface. Be careful, okay, it's not a class. So this Q is an interface. And over here, we also import iterator. Okay, iterator interface. And we also import another class. And later on, we will learn this, okay, linked list class. Okay, and how do we use Java collections? Okay, the generic Q. So this is similar as you remember in the previous chapter, we learned stack. Is it the generic stack? Is it? And similar, okay, concept here. And okay, so let's see, how do we use this Q? So to use this Q, you need to do Q and angle brackets. This is mandatory, you must have this, okay? And you must plug in with object. Is it? Here it's an integer, okay? And when you call new, when you want to create the instance, the object of Q, you cannot do new Q, okay? Because Q is an interface. You cannot use interface. Cannot use interface, is it, to create object. Okay, so that's why you need to pick some class. This is a linked list class. But this class implement that Q interface. So that's why you can do new linked list, okay? And you can just leave this empty, okay? So it will automatically take integer type, okay? So anyway, this is a linked, this is a Q, okay? And for the official Q, Java official Q, okay, it doesn't call add at back as in Q, it call it add. Okay, with this add, it's add at back. Okay, remember, okay. And also it doesn't have full condition, so you don't need to worry, okay, unless run out of memory, okay, but that's another cases. But generally, there is no Q full condition, okay, so that is add. And we also have, this is corresponding to our front method. So you want to get from, you call pick, okay, just like a stat, as we also have pick. And it also has the two strings, so same thing here, okay. And then next, let's see. Over here, then we also have our search method. Later on, we will take a look, this is search, how it works. And another one for Java collections queue, it also has a method called contains. So basically, this is the search method. Search an item. Okay, so if you can find it or not. Okay, you can also call the contains. Okay, if you want to search with the generic one. Okay, so that is the general information about generic queue. So what next over here, you see, we also support the for each loop here. Is it? So for this generic queue interface, is it? So this is generic queue, is it, from collection library? But this Q1, basically, its type is linked list. Is it? It's a linked list object. Is it? And the linked list, it implements that iterable interface. That's why you can also use the for each loop here. Okay, so that's why. Okay, so anyway, with the generic, it also support the for each loop. And we can also do another kind of for each loop. Okay, and this for each, it's a method. Okay, later on we will learn it more in detail. But anyway, here, just give you some idea. And this is a method, is it? And it belongs to that linked list, okay? And it's doing the same thing, loop one by one, okay? And who remember what this is? What is this? This?
Lambda.
Yeah, so this is very good. This is a lambda expression, okay? Okay, so later on we will learn a lot, quite a lot of this. Okay, so anyway, so you can also try to use this kind of loop. Okay, and this is a parameter. Is it? This parameter is basically some item in the queue. Is it in the queue? And then you can retrieve each of the items. So not a lot of new things here, okay? And next, let's see, with the iterator, is it? And the iterator is an interface, is it? Iterator itself is an interface, is it? Itself is an interface. And over here, we call linked list, is it? So this Q1 is a linked list. Linked list. Is it? Linked list implements the iterable interface. Is it? And that's why over here you call this data iterator. This data iterator is from this iterable interface. You override it. Is it? You override that. Is it? Okay, so anyway, linked list also provide that iterator method. Is it? And because of this iterator method, is it? And over here you assign that iterator as to this iterator interface. That's okay. Is it? Like previous we learned. Is it? And because it's an iterator, this number Q iterate. That's why over here, did you see? You explicitly can call has next and next. Is it? Has next and next. And you can also try to call that to remove. You can also call number Q iterator. Is it data remove? You can also call it. Is it? And you call remove. And it will then So the loop won't be broken. You can still do it. Is it? You can still do the loop. Is it? So this is why we have this kind of iterator interface. Is it? Because you can also remove. Just think about it. If you don't have while loop, is it? If you use a for loop instead here, then that will cause a problem. Is it? You remove and you're going to loop 10 times, suppose. But you already remove one, is it? So you cannot loop 10 times anymore. That will cause issue, is it? So that's why over here we have this iterator interface. Is it? Because it will give you more flexibility. Even though you do the remove, it won't destroy the pointer, is it? The iterator. So that iterator will not be lost. Will not be lost due to remove, is it? Due to remove. Or add, is it? You can also add, is it? With this kind of loop, you can also add an item, is it? And if you call add, okay, that also won't break the loop. Okay, so that's what this iterator's purpose. Okay, with this iterator, there is another for each remaining. Okay, you can also do for each remaining. Okay. And then next, let's see. So this search method is pretty similar as what we learned before, is it? And over here, but the second parameter is a generic queue. Okay, and with this generic queue, how do I create a deep copy as if for linked list? Okay, and generally speaking, later on we will also see with secure programming, generally we don't promote to use clone. Okay, so in collection, it has a specific method. If you want, it's kind of like a clone, but it's not a clone. Okay, it's called add all. Okay, this add all method will copy your queue, is it, to a new queue. So this is going to be a deep copy also, okay, so that you don't need to worry the remove, okay. So you are going to add item by item to the copy, okay, to the copy. Okay, so that is this method. And what next? We have a little bit of left over the concept. Let's take a look here. Okay, so examples of queue. Okay, so over here you can see it's input and output buffer. We can use queue, screw, DAC. Okay. Oh yeah, there is another new. It may be in your lab or in your assignment. Okay. So this is called DAC. So pronounce as DAC. Okay. So it's a double-ended queue. Double-ended queue. Okay, what this means, it means you can add and remove at both ends. So not just add at the back, you can also add at the front. And you can also remove at the back. Okay, that's what this DAC means. Okay, and over here it shows from a file, and we can use a queue. Okay, so like over here it shows some file, is it? And the file stored in some external disk, is it? External drive, is it? And you are going to, you remember we do, this is C++, okay. So we can do scanner, is it? And then you can you can get the contents from the file to the memory, is it? So over here, it use the concept, it has input buffer. Input buffer will keep the order of your original file, is it? You don't want to change it, is it? So that's why this input buffer, the concept basically it's a queue, is it? And then you may need to have something to CPU to process, is it? And then output some contents, is it? So that's the idea here, okay? So anyway, so here input output buffer, we can use queue. And then what the next one shows is called scroll. Okay, scroll. So it also has something related. It says queue on one end, stack on the other end. Okay, so what over here is, you see, when you do keyboard, is it keyboard? We can do backspace. Is it backspace? Is it? So the backspace, basically it's a stack on the other end. Is it last in, first out? But that's just at the back, is it? But the front, did you see, for your keyboard, load it to memory, is it? We call input buffer. This part, it still follows first in, first out, is it? But of course, it also supports backspace, is it? This concept, we call it scroll, okay? Okay, and then the next one. The next one shows us, is it like our screen? Is it, you can, for screen, you can scroll down. Is it? You can also scroll up. Is it? So that's kind of like the double-ended queue. Is it? Because if you scroll down, then some parts will be out of sync. You cannot see it. Is it? This part you will not be able to see it. Is it? Then you will see the upper part. Is it? So, and then later on you screw back. Is it? Screw back. So you will bring it back. So that's called double-ended queue. It's called DAC. Okay, with the screen handling. Okay, so that's how we use it in our operating system. So, and another usage is printer. Is it? But over here they discuss multi-user. Okay, so like in computer lab, is it, you only have a single printer, is it? But the students, multiple students can print, is it? How do the printer keep track of each student's file to print, is it? It's first in, first out, is it? Yeah, so the printer queue, is it? And whoever is at the front, then it's going to start to print the file, is it? So that's the concept here. Okay, then the next one. The next one, so it's in operating system, is it on disk and in memory, is it? And there are a lot of concepts. We have something we call resident queue, is it? And we also have suspended queue, is it? Suspended queue. And and the ready queue, is it? And the ready queue. So all of this kind of concept, is it? So here is in disk. So all of your files will be aligned in disk as first in, first out, is it? And then your memory will load following first in, first out, is it? And this ready is also a queue, is it? It's first in, first out to CPU, is it? And of course in CPU, something you may have I/O request, is it? And whenever I/O request, it's suspended, is it? It is moved to back to memory, is it? To suspended queue, is it? And waiting for input and output, is it? And then it's finished, is it? So over here you can see operating system also heavily use the queue concept. And the last one, we will see it's called priority queue. Priority queue, okay. And we won't do any examples or but the idea is priority queue is the item also assign with some priority. Okay, with priority. So even though 6 is supposed to be added here, is it? But the 6, because it has a high priority, is it? So it is added at front, is it? And for another one, it's supposed to add at back, is it? But it's not. Based on the priority, it's inserted in the middle somewhere, is it? So this concept is called priority queue, so that you guarantee high priority is at the front, okay? Okay, so that's the general information of the information for today. And basically, we complete the study of queue. Okay, so next we will next